Can you see this? เห็นภาพชัดไหมครับ sorry
Okay ค่ะ
โอเคเห็นแล้วนะครับ
ค่ะ
Okay, so in this picture you can see many types of the air conditioning in this picture. I took this picture in China. Okay, in this picture is the a special air handling unit, which is they have built and they put a clear plastic you can see inside. Okay, this one is like uh, the dedicated outside air, okay, to fill up the air conditioning in the buildings. Okay, and also they have many types of the fan coil, which is they have the ducted or the cassette. Okay. Oh, all right. So I will go slowly, okay, on this because they have many complicated, which is if not familiar with that, it will be lost. Okay. So in the air conditioning system, okay, for the air conditioning system, we have the how we divide it. Okay, when we are divided, we divide it into how it heat reject in the condenser side and how we deliver the cooling distribution. Okay, so air conditioning in the bigger picture is like, okay, when we talk about the heat rejection, when we heat rejection, we have for air cool, we use the coil and the fan to cool down in the condenser. Okay, sometimes you can see the big like the big tank up into the building. So it is like it is the cooling tower, and it will be water cool chiller. Okay, sometimes they use the pond cooling also. They reject the heat in the pond. As far as I know, in Thailand, I know only one or two places which is the use pond cooling. Okay, this one is the heat rejection type of the air conditioning system. And another one is the cooling distribution. For the cooling distribution, they have the air distribution and also chill water distribution. Sometimes when you produce the air, you go direct and you put into the air handling unit and the fan coil unit. What is the air handling unit and what is the fan coil unit? Okay, very simple. If anything that moving, they have the blower and coil inside. Okay, if they use the single phase motor, if they use the single phase motor, is the fan coil. If they use the three phases motor, is the air handling unit. Okay, very simple. Okay, but it is exactly the same function. Okay, and the chill water system, we call it a chiller. If we produce the chill water, so it will call chiller, we will call it chiller. Okay, down here you can go back and have a look on the YouTube, or you want to see, I just show you a bit. Okay. Okay, maybe later. Okay, the type of the air conditioning. Okay, this one air cool. Okay, you remember? The first one is the heat rejection. Okay, first one is air cool. Okay, air cool. This one split type at home that you normally use, we call split type unit. They have fan coil and they have the condensing unit, which is they put outside. So when they have a condensing unit, they send the refrigerant into the fan coil unit, and then it used the room temperature and boiling the refrigerant inside, and then they give the cold air to the occupant. Okay, this is a split type. Okay, so this is very simple, and we mostly use in home, apartment, or residential area like the condominium also. Okay, this one is rarely used now. Okay, it's very popular in the 80s and 90s in the building. So they have the condensing unit and evaporator, sorry, an AHU unit. The AHU is on, it sits on the top of the condensing unit. Okay, so we call it package air cool unit. It's like a big window type aircon. Okay, so they have to use the air outside to cool down the condensing unit, and they have the condenser air out. They have condenser air in and condenser air out to remove the heat from the condensing unit down there. And from the upper part, they will use the return air from the room, and they have supply air to the room. So they can supply either this one or front, okay, or the other side also. So this one the same. So from the room, you supply the cold air into the room to the occupant, and from the room you return the air back to the unit. We call the package air cool unit. This one is rarely found in Thailand, but nowadays it's not popular anymore. Okay, because the design mostly is designed as per the U.S. Aircon, like Carrier, Train, or York. Okay, and they have a high side, very high, so it's difficult to maintenance. This one is the air cool, also air cool chiller. Okay, so you can see this is a chiller. The chiller, they have a fan. Okay, they produce the chill water. Okay, this one is a condenser fan. They reject the heat out, and then inside they have a cooler in evaporator. So they produce the chill water. They produce chill water into the pumps. Pumps send the chill water to the air handling unit. This one air handling unit. Okay, when they pump to the air handling unit, they uh, deliver the cold air into the room, and also from the room they have a return air back to the air handling unit. Okay, this one you can see in many shopping mall. Okay, shopping mall in Thailand that use the air cool chillers like SB Furniture or the Home Pro, Mega Home. This one mostly they use the air cool chiller. Okay, some factory, most of the Japanese factory in Thailand, they use air cool chillers because it's easy to maintenance. Some hotel in the north of Thailand and in Bangkok, in many places, they use the air cool chillers, and also hospital. Most of the big hospital in Thailand, they use the air cool chillers in many places. Okay, let's say the Rajvithi Hospital or the Sirirat or Chulalongkorn Hospital, they use air cool chiller, for the small building. This one is water cool. This one is a package water cool. Okay, the package water cool is the aircon, which is the self-contained, and how they reject the heat. They reject. Okay, this one, the bottom part, we call it the condenser, water cool condenser unit. Okay, so this one they reject the heat by pumping the water from the cooling tower. The green one is the cooling tower, and then they pumping back to the condenser unit after reject the heat, and then they send back to the cooling tower again. Okay, this one is very it's quite efficient they're still using in many office building in Bangkok. Okay, in 90s they have so many office building in Thailand. They use the packaged water cool, and okay, as you see, the upper part of the packaged water cool, it is the evaporator, or we call it the air handling unit inside. Okay, so they use the return air from the occupant rooms back to the packaged water cool, and then they supply the cold air in the room. Okay, this one is a packaged water cool. I myself sold this packaged water cool about almost 30 years ago, 25 years ago. They're still really popular, and also in the factory. So yeah, this one is water cool. It's the most popular at the moment. Okay, so okay, from the chill water side. Okay, from the chill water side, this chiller, the green, sometimes they are yellow, they are light, they are gray. So the chiller color is doesn't matter. So chiller will produce the chill water through the pumps, the chill water pumps, and send to the air handling unit. In the air handling unit, they use they accept the return air, and then they supply the cold air into the rooms. Okay, but the difference from the air cool chillers and water cool chiller is on the condenser side, they use the water as the media. Okay, through the pumps and reject the heat through the cooling tower. This is the cooling tower. Okay, so this is a multi-cell cooling tower, quite high efficiency. Yeah. So this one will have the efficiency. Okay, the water cool chillers has better efficiency than air cool chiller in theory, more than 25%. Okay, sometimes it's 30%. Okay. So in the big building, let's say in the shopping mall, central department store, or the mall department store, large building like the hospital, the big building like the Poparo in Chulalongkorn Hospital, Ramathipadi Hospital, Chakki Narupadin, or the factory, the huge factory like the WD or Hitachi, or many factory, they use the water cool chillers. This one has been popular because it can design at the very high efficiency system. So many shopping mall they use, because in Thailand, apart from the factory site or the industrial site, shopping mall is the most power consumption. The numbers, this one is number one in Thailand. It's a shopping mall, consume a lot of the energy. This one you can check in the EGAT website. Okay, so most of the energy in the buildings in Thailand, 60-70% is consumed by the air conditioning system. So this one is the most important and crucial equipment system in the buildings. Okay. Oh, this one is the variable refrigerant flow,
I have a
VRF.
question before you go to VRF.
Okay.
When it seems like water cooled system seem to be great and very energy efficient, why not all the building use water cool system? Why do they still use air cool system?
Because the first one is okay, I explain a bit. Okay, the air cool chiller, actually they very efficient already. I mean, they can balance the load, and they can use the load. Okay, let's say if you use if you use chillers comparing to this type, comparing to the split type, let's say in the hotel 100 room, okay, you have to turn on the aircon 100 rooms to get the full hotel cold. But if you use the air cool chillers, you may use only, you turn on only 80% or 70% of the chillers and make the whole building cold, because the load in each rooms is not the same. So they are sharing the load in the buildings. Okay, I talk about I go back a bit on the air cool chillers. Okay, the chillers, it helps to balance and also the sharing the load. So that's why they have more efficient than the normal split type unit. Okay, okay, back to why air cool they are so popular in the building, and why they not use the water cool. The major thing is the investment cost. The air cool chiller is much cheaper than the water cool, because you have to put the piping, you have to put this one is air cool. You need only the piping or the chill water and the piping for air handling unit. But look into this, the water cool, you need to put a lot of more equipment. Let's say piping for the condenser, okay, the condenser pumps, cooling tower, and actually to support the cooling tower and let it works well, you need to put the water treatment plant to control the water quality in the cooling tower also, and the system controlling is more sophisticated than the air cool chillers. Okay, so when the owner would like to invest, they will consider a lot on this, because if the size of the building is not that big, let's say the hotel, okay, the hotel water cool, you have to use like 300 rooms or 400 rooms and over, then it's justified to use the water cool system in the building. But if the majority of the hotel in Thailand is 88 rooms, this one may not be a good choice. Okay, so the air cool chiller is very easy to install and maintenance, and cheaper than water cool. Okay, but comparing to the air cool and the VRF at the moment, the VRF now the price is come down. In some cases, they are even cheaper than air cool chillers. Okay, and more efficient. Okay.
I see. So it depends on the sizing and also the size of the project, whether if they can invest and the payback on operation energy saving will be good for them or not ใช่ไหมคะ so that
Yes.
they will
Yes.
have to consider which system is good for them ค่ะ
And not only that, because when you put the large tonnage chillers in the building, the people who have to play important roles is the maintenance engineer or supervisor or technician, because I have seen with my own eyes in the hospital in the rural area, like sometime in Isan or in the northern of Thailand, the chiller is in the building, in the hospital, and it's not operate because they have not enough maintenance and it's broken. So yeah,
that's sophisticated, that's why.
So people they use janitor พันโรง to open the chillers. What do you think that they will have a good maintenance? So sometimes they did not consider to spare the budget for the maintenance people. Okay. So this is the why when we talk about the large system like the air cool chillers or water cool chiller, you need to have the people with you 24 hours. Okay. for the buildings that operate 24 hours, sorry.
I see.
Okay. So next one is the, I think VRV has been introduced more than 30 years ago. By I can say that I have to give them applaud that basically they try to do this system 30 years ago, okay, by trying to use the advantage of the sharing balance of the chillers. Okay, so you can see that in the picture. Field module of the condensing unit can hook up with the multiple fan coil in the area. So in some cases, they did not need the load, so they can sharing the load together in this area. So the VRF system will be part load, and currently the VRF all brands have the inverter already, so the power consumption even better than the air cool chiller in many cases. Okay, so I can say that VRF is very popular at the moment, and I can say that very low maintenance comparing to chillers. Chillers, you have to understand the water, you have to understand the treatment of the water, but the VRF, you treat it as the big package split type. So it is very easy to maintenance. When you turn on, it runs. So very simple. Currently, the office building, many office building, if not big building, they use the VRF. Okay, shopping mall, they use VRF because they want to reduce the investment cost and maintenance cost. Okay, last time, uh, the price of the VRF is like almost double of the chillers. Okay, at the moment it's cheaper. I can use rule of thumb like 5 baht per BTU or 4 baht per BTU, including installation. Comparing to the chillers, chiller is about the same, 5 to 6 baht per BTU. Okay, but the chiller have to be the big large system. Okay.
What about the regular split type systems? How many baht per BTU?
About 2.5 to 3 baht. Okay.
I see, but then why not shopping mall? They use split type, huh?
Because the shopping mall, they would like to sharing the load. As I said, the shopping mall, they can utilize the load. So let's say if you put the split type, you have to put like 100 tons, something like this. But when you use the VRF, you can use the condensing unit at 80 tons. So they can have they have we call it the diversity factor by sharing the load. So the shopping mall, they okay, Thai Wassadu, they use the VRF. Okay.
Then
And
the university should we also have the VRV for classrooms building?
if the classroom, okay, before I talk about the disadvantage, I talk to advantage already. It is easy and put into the classroom. I think it's good. Okay, but okay, they have but VRF. You have to think that it is the split type unit. So the lifespan of the VRF system is like 15 years maximum. I think 15 to 17 years, the maximum. So comparing to chillers, chiller is much longer. 20 years, 30 years, you can still see it running. Okay, so in the VRF, in the education system, in the education like school or the university, it is good, but you have to zoning it. Let's say this floor, okay, use 2-3 units this floor, so you cannot combine. You may combine together, but for me, I still quite cheer up on the water cool chiller rather than VRF, because VRF is the very suitable for the unit, which is in between 100 to 300 tons system. Okay. But myself, I saw one few project which is 1,000 tons, 2,000 tons in the hospital also last few years ago. But it divided in zoning, so it's a little bit different from the water cool chillers. Okay. You can see now the equipment, Tang Salapao, or you can see the cooling tower. This one, they have two types. One type is the like this, the multi-cell. Okay, it is the multi-cell, and this one is one unit, like 500 tons or 400 tons cooling tower. This one air cool chillers. This one water cool chillers. Okay. This is FCU. As I said, FCU is like they have coil, they have motor inside, but it is a single phase motor, so it is the FCU. But air handling unit is three phases motor, so we call it air handling unit. This one is very popular now. In the past, people, they are scared, especially designer in Thailand and architect also in Thailand, that they are scared that to put the outside air into the building directly, it will make the whole system of the air conditioning consume more power or energy. But after they have so many research that if we have a dedicated outside air system, forced the outside air and put into the building and treat it, take the moisture out, take the contaminants, take the dust out, and then put into the building, cooling it down. The power consumption for the whole building is cheaper than the conventional ventilation system. Okay, so the fresh air unit is more popular because of today we would like to control the outside air into the building as per the law and as per the ASHRAE standard 62.1. So the fresh air unit is the play important part for reducing the humidity and also the PM 2.5 also is one of the things that they have considered to put this fresh air unit. Why we need it? We need to centralize the air conditioning of the ventilation air. We can improve the dehumidification performance of the basic constant volume system and enable affordable use of air-to-air energy recovery. Okay, you can see this picture. Okay, the picture will OA is outside air, EA is exhaust air. Okay, RA is return air, and CA is constant air. Okay, I'm not sure on the CA, but I think it's the constant air. Okay, so when OA is in, it will take the outside air. It is hot and humid. So when it hot and humid, they pass the filter and pass the heat wheel, total energy wheel. This wheel will exchange the air going out and the air going in and exchange the heat. So the outside air will be colder. Okay, when it's colder by exchange by the energy heat wheel, this one will have a colder air. so it will have a better temperature, okay, and it pass the filter, pre-filter, medium filter, and put into the buildings and into the duct, okay. So when put into the buildings already, after past so many occupants, then they are returning. This is a return air, so they have a return air passing this, and also heat recovery and exhaust. Okay, this one will control the modulate. Okay.
Oh, I have a question. Will also the humidity reduced from the total energy will count, or only sensible
No,
heat?
no, only the sensible heat, cup. Only the sensible heat.
I see.
So how to take out the moisture if you use the cooling coil? In some case, in the cold country, sometimes you need a heating coil. Okay,นะครับ. So the outside air will pass the total heat, total energy will. So the outside air will be, temperature will drop a bit and then passing through the cooling coil. So when you pass the cooling coil, it will take out the moisture, and then they pass through the blower, and the blower they will send into the supply air into the space, or supply air into this fan coil, into the space. Actually, this one they send into each area or zoning, and each zoning they are collecting back into the return air, and return air you have the return back to the heat total energy wheel. Okay, I always say that is a heat wheel. Actually, it's not heat only; it's the energy wheel. Okay, so in the return air, sometimes they put the bypass also. Okay, if you not use the total heat energy wheel. Okay, this is the schematic of the outdoor air preconditioning. The criteria. Okay. We back to the criteria. Okay, criteria of the air conditioning. What we need is to check the performance requirement, the capacity requirement, the spatial requirement, first cost, operation cost, reliability and maintenance, flexibility, location, and type of the business. Okay, so this one is the key criteria that you can use for the selecting the system, whether you use the chiller, water cool chiller, air cool chiller, VRF, split type, and package water cool. This is the criteria that you have to consider. This is the rule of thumb. Rule of thumb for the load. Okay, let's say for the office, normally we use 16 square meter per tons. And corridor, ballroom, pre-function, function room, restaurant, suki restaurant, and also the lobby, lounge, shop, fresh air unit. Okay, so this is you can use this rule of thumb. I think it's quite useful if you really need it. I think. The condensing unit that I'm talking about, the split type. Okay, in the split type, you can see in the apartment or in the condominium, you have to be very clear that you have to. Okay, I have some case. Okay, in the case that in the Rashada Road, they have one condominium, luxurious condominium. They use the condensing unit. Each floor they use a condensing unit, but the problem is in the in the system which is above 15 floor, they cannot reject the heat. I mean, the condensing unit have problem. They have the high pressure, so it cannot be ventilated, and they cannot have the airflow through the condensing unit, because for the high building, the wind that exposed to that site is very heavy. So the condensing fan cannot get through, so they cannot have a good ventilation. So the condensing have blocked and the aircon is not work. So that is one case. So they have to replace all of them. Okay. So when you design the split type for the high-rise building, you have to be careful, especially for the condensing unit. You have to identify for sure that the place that you put the condensing unit, they have no block or any windy places which is can block the ventilation of the condensing unit. Okay. Secondly, on the air handling unit, in the building, you can see that in the building they have the air handling unit. Let's say this in this building. So they have the air handling unit here, air handling unit room, and this side also have the air handling unit room. Okay, the rental space is 2,000 square meter. Okay, so the air handling unit space is around 4 to 5% of the total condition area. Okay, so any condition area more than 100 square meter, you should have the air handling unit rooms. Okay, every 400 square meter, you should have one air handling unit rooms. Okay, and the air handling unit rooms should have the duct which can go in at least two-sided, and two-sided have to next to the area of the air conditioning area. So this one have to. This is important. So I try not to translate because I may translate wrongly. Okay, because the width of the room is important. So this one is because people who require the space mostly is the designer, especially architect. So they have to understand it. They have to understand that they have to have a duct, supply and return. Otherwise, if they don't have space, they cannot bring the air back to the room, and it's not efficient to the system of the air conditioning. Okay, this is a handling unit room.
I have a question on this picture ค่ะ เนี่ย it seems to have AHU 2 rooms on this floor. It looks to me like 15% or more, much more than 4 to 5%. อันเนี้ยแสดงว่าอันนี้ก็ can it be only one room or it has to be 2 rooms but smaller?
I think it's 2 rooms smaller, but this one take from somewhere. I think they can entertain the space of the air unit. I haven't seen like this before. Normally, it's much lesser than this.
I see. Yeah, this is so big compared to the floor area. Yeah,
correct. Thank you. This one also important. The ceiling space. The ceiling space. You can see they have so many things inside the ceiling. Not only the piping, the chill water pipe, they also have the duct work. They have the sprinkler or the firefighter or the piping, the electrical cable, everything. So the ceiling space, I mean the mechanical designer wish to have more than 900 millimeter. Okay. At least.
You mean for overall ใช่ไหมคะ including air
overall
and electrical duct?
Yeah, everything.
Oh, this is important, students. I want to stress out because in many of your design section, you only have floor and another floor. You don't have ceiling, nah? So you make sure that in your cross section in your studio design, you should put like 90 centimeters for large building ใช่ไหม but for condo, what should it be คะอาจารย์คะ the ceiling space also.
Condominium is different because the air conditioning, the system is not in the ceiling mostly, so they have a lot lesser.
I see. But anyway, you should spare maybe 90 centimeters,นะคะ, because we have a lighting as well, also ceiling structure, and therefore you need to spare this. Therefore, floor to floor, it can be maybe 4 meters. If you want to have ceiling height around 3 meters,นะคะ, student ค่ะ ขอบคุณค่ะอาจารย์
Yeah, okay. This is the key things that I'm think of. Okay. Also in the mechanical room or the chiller plant, okay, in the chiller plant you can see that they have to have a space. If you look into the water cool chillers, especially on the water cool chillers, you can see that this side so empty. Why? Because the chiller in the shell, okay, they have a shell and tube inside. They need to do the maintenance. So you have to put the เขาเรียกอะไรแปรงนะครับ brush to a long brush to put into the piping in the tube of the condenser in this site. So that's why they have to spare the space, at least the half of the length of the chillers, or the best is the same as the chillers size. Okay, like this one is this room is a bit difficult to do the maintenance, but can do. So we have to take out the piping, and then we do the other side. Okay, a mechanical room, it is an art also. If you can make it simple, clean, it will be easy for maintenance also. Okay, I have seen in many shopping mall, they are not well planned. So it's like the เขาวงกต like we win.
I have a question on the location of the chiller room ค่ะ.
Yes.
Sometimes they put it on the basement or first floor, but when there is a threat of flood sometimes, and we don't want to have a disaster from flood, if where should we put on if on the second floor, then I don't know how do we do the maintenance, like do they have to have crane and open the door opening from outside in order to maintenance? Do you have any recommendations?
So the easiest is you have to put the chiller plant. Let's say this chiller plant, they have a space. They have a space which is for me, either basement or in the first floor or the ground floor is the best. Okay, in the basement, sometimes when they have flood or the pump, the submerged pump is broken, they might have some problem also. So
The first floor
so
maybe good ใช่ไหมคะ
maybe good, or the second floor. It doesn't matter that if you need to do the maintenance or the overhauling, if you have space enough, it's okay. But most of the time they don't have much. We cannot entertain that much space in the building. So sometimes the building they are okay. Let me share like this. Okay. The chiller plant that I can say that one of the oldest chiller plant in Thailand is like MBK. I think everybody knows that. MBK, they have a chiller plant on the 7th floor. They have to use the mobile crane to bring the chiller into the machine room on the 7th floor. But they have a platform whereby you can put the chiller in, slide in. So it will be very next to the cooling tower up there. The cooling tower is on the 8th floor. So the piping and the power consumption is a lot lesser. If you have the pump down in the basement, you may easily take out chillers, but in terms of the energy consumption that you need to pump the condenser to the cooling tower, maybe not that lower as the current one. Okay.
I have a question that during the flood time, okay, some they put on the basement on the first floor. Do we need does it cost a lot to fix it? Should we think about because either on the first floor, but we allow the flood to come in, but we fix it, or what do you think we should put on the second floor and invest a kind of ramp or access for maintenance? I'm not so sure about the fixing when there is in case of flood. Do you have
Oh,
any?
in case of flood, I can say that you cannot avoid this. So everybody has the same problem. So
Yeah, yeah. So what shall we do?
so we have to be okay. The first one, the big machine like chillers, have to stay nearby uh, the power source. Have to be nearby the transformer.
ค่ะ
Secondly, it has to be the most centralized of the buildings, which is no need to pump the water so far away. If you are in the middle of the building, the 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 pumping will not have consume much power. Okay. Third one, it has to be near to the cooling tower, so the condenser pump will be a lot lesser. Motor will be a lot lesser, so it will have more efficient. Okay, so the 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 flood that I think it is not normally they think about it, but not that big consideration comparing to these factors that I mentioned.
Yeah.
So the
So,
mechanical
mm,
they will ensure that you can see the chiller plant like this.
ค่ะ
They have a MDB next to the chiller,
อืมอืม
so so they have a cost saving if you put the MDB outside or the other floor. So the cable will be very expensive. Okay,
I see. So,
so
so if
uh,
students have a chance to design, okay, the criteria for a chiller room is near the center, near the MDB room, and
and can
if
accessible.
possible,
Yeah,
yeah, accessible, and also to avoid the flood too. Because I think we are in the resilience era that we cannot afford
yeah.
the loss
Another
due
yeah,
to
another
the flood.
20 years, Bangkok will
Yeah.
be
Right,
in the
right.
water.
I would leave to our young generations to please consider because now your design becomes more difficult, where you have to think a lot about the criteria นะคะ in your design ค่ะค่ะขอบคุณค่ะ
Correct. Okay, the next one is a cooling tower. This is the classic case. You can see this. This is the cooling tower and they have a hood. Cooling tower, normally they have some moist dissipated out of this cooling tower. So they have to ensure that they have a flow out well, not not put into the space which is go back to the buildings. Okay, so this one is the cooling tower, but it's huge one. Okay,
At
be
least
careful
how
on
many
this
meters
also.
per
That cooling
one?
tower, you can see the cooling tower is inside the building. This is a short circuit. I can
At
say
how
that.
many meters that can you recommend not to be near the the window?
No, not to be. This is inside the building, which is short circuit inside.
No
You can
at the
see.
cooling tower ที่มันเป็น
Or
เป่าๆ you said it have to be far away from
you can see it's a 6 meter at least 6 meter.
IT
But it depends,ครับ. It depends.
ค่ะ
Okay. So many brand in Thailand now, they have old brand like Lingchi is from Taiwan. And they have so many. Okay. Malay or Iwapco or many. Okay, the cooling tower plant is you can see is like next to the chiller plant. Okay. One moment.
how many meters that we should be too far apart? Okay, you said cooling tower plant and chiller should be closer to each other. Then how far shall we are we allowed to have the location different?
It depends. It depends. No problem. It depends on the location. Sometimes the location is not.
I see. ค่ะ
not suitable ครับ It's not. We cannot say that okay. Rule of thumb is what? No. It depends on the space that you use and the design ครับ Okay. So this one is a mechanical area. Okay นะครับ This one in the hospital. So in the hospital, you can see that they have a special air handling unit in the ceiling, and in the ceiling they have many type of the air handling unit. Okay, they have so many measurement inside. So in the OR or the operation theater, they have the air up there, and they have a flow of the air lamina to the people who have been operated. Okay.
I see. So the picture on the top here is the picture above the ceiling of the operation
Yes, correct.
room ใช่ไหมคะ Well,
Yes.
what is the space required คะ
As much as much as we can.
โอ้มันเป็นซีลิ่งเป็นคอนกรีตเลยเหรอเป็น
ใช่ครับ
พื้น That's a floor designed for all the systems above
But this
the
one is, I
operation.
can say that it's quite compact. Actually, they should not do like this. They should have more space.
I see.
But for the hospital in Thailand, it's like this. It's normal.
ค่ะ
Okay.
Can you explain
and the
lamina
hotel
again?
guest.
You mentioned about lamina.
Okay. The flow that we use in the OR, they have to use the special diffuser. Okay, in the operation theater, they have to put the diffuser which is can distribute the air from the top slowly, very slow. Okay, to make sure that the air pattern is laminar, not a turbulence. Normally, the aircon in the
lamina they don't know.
ไม่รู้จะอธิบายยังไง
Maybe
ไม่เป็นไร
slow
ครับ
air
เดี๋ยวผม
movement.
ค่อยหาแล้วส่งให้
Very
Yes,
slow.
you can say that is very slow air movement,
Okay.
and the pattern is like it's not turbulence. It's not have any yeah, very slow. Yeah, it is asymmetric, unifying, same velocity. Yeah, very slow. Okay. And this is the typical hotel guest room. Okay, you can see that they have not in this hotel guest room. This is they have a guest room right and left. Okay, this one is the aircon. Okay, in the air, no, this one is the aircon. So they tap the chill water in to the shaft. Okay, in the shaft they also have many piping. They have a plumbing piping in the. This one is what? This one is the toilet. They have a bidet and also jacuzzi. Okay, so in the shaft you have to design and ensure that they have enough space in the room shaft. Okay. When you talk about the VRF in offices, okay, I can say that you may got the job from the owner, which is they currently use the split type and they want to change into the VRF system. So when you have to make sure that the exhaust, they have enough space to put the condensing unit and put the duct to reject the heat. In very high building, the site that you put in this, as I told you that I tell you the story that the very high building sometimes they have a wind blocking this and make the condensing unit cannot uh, reject the heat out of the condenser. So it will create a problem. So when you design on this, you have to ensure that you have to go to the job site yourself and then make sure that this one is not having the air block into the this type of the
Mhm. May I ask how to design, like they should put the facing of the fan away from the facade or something? Is there any
yes correct
recommendation ใช่ไหมคะ
that ใช่ครับถูกต้องครับ yes
I see.
โอเคครับ so
And
I
and
think
and is there any limit for the VRF systems for condensing units and
nowadays the
and
condensing unit of the VRF is very advanced. It is like a chillers already, I can say. So each module is bigger and bigger. Now one module is 26 horsepower, whereby it's about more than 20 tons. So four unit is 80 tons. 5 unit is the 100 tons already. So it can substitute the air cool chiller right away, and they still have the same effect like the air cool chiller, which is they can sharing the load. Okay, when they sharing the load, they create the diversity factor. Diversity factor, let's say นะครับ so let's say this side of the building, the fan coil like this on the east นะทิศตะวันออก in the morning they have sunrise in this area. So when they have sunrise in this area, the load is here. So this one will open the electronic expansion valve 100%. And this side, no sun at all. The western side, no at all. So when they put the condensing unit here, it will work maybe 60% of the load and of the total load. Okay, when you off the total load 60%, the VSD or the inverter of the condensing unit in VRF will working. So it will consume a lot lesser than the normal system or the split type system. In the other way, in the afternoon, they have no sun in this area. Okay, it's the east side, but they have sun in the west side. So the load will be open here 100%. Electronic expansion valve in this side of the building will open 100%, but this side maybe is only 50%. So the total load will be less than 70% or 80%. So anyways, the VRF will help you create the load sharing and the diversity factor similar to the chillers. So that's why there's
Yeah, I have a question. Students, their studio design on the second year isอะไรวะ home working condo นะคะ What
Yeah.
kind of systems do you recommend for their home working office home
office or
เป็
home
นเหมือนคอนโดใช่ไหม student จินตุธา what is your studio design this year
Town
this
home ครับ
time อะไรนะ
Town home office ครับ
town home office ค่ะ
oh so town
ตึก
home
แถวอะครับ
office in the town home office in the night they use for staying in the night sleeping, right? And the daytime they use for the office. Am I right?
ขายรายได้ครับ
yes ครับ
Oh, okay. So I think the easiest way for meนะ, you just put the split type, but you put the inverter. I recommend like that because they have so not many in terms of investment a lot cheaper than VRF, and it will create the same effect similar to the VRF. But in the large in the large spaces like this, I prefer VRF because the price
see,
will be
I
more or less
see.
the same. But
because
for the small unit,
small unit ใช่ไหม they don't have to
ใช่ครับ
depend on others ใช่ไหม so they have independent system ค่ะ
So the
อันนี้ก็
the
not to
inverter is
be
the
more
most
than 10
important.
the condensing unit shouldn't be greater than 10 meters from the unit ใช่ไหมคะ
For VRF not ครับ if
ไม่ for
VRF
the project อ่ะ for student
for project try not to more than 8 meter ครับ the best นะครับ 4 meter
Oh, so
because when they
students have to prepare the place for putting the condensing unit ใช่ไหม that is
ใช่ครับ
shaded
and have to be careful
ventilation
on the maintenance ด้วยนะครับ when they have to clean it they are ไม่ใช่เล่นกายกรรมปีนตึกข้างๆไปไม่ได้นะครับ
Okay ค่ะ thank you so the student they have to provide a kind of access doors ใช่ไหม from maybe
Or
from the main area to the condensing unit ค่ะ
why I have recommend for 4 meter because the split type that they have tested in the factory and got the Mark 5 from the EGAT. Okay, when they design in the best efficiency, they are designed at 4 meter ครับ
And
The
may I
piping
ask the interior students, what is your the second project for interior students คะ So you might ask อาจารย์อุทัย what are the systems interior
มี
student
dormitory ค่ะ
pardon
we redesign the dormitory
or dormitory design
how big how many rooms ครับ
เอา pitch ตอบอาจารย์หน่อยค่ะ pitch
I think 5 stories
5 stories. Okay. You can also use this split type with the VRF or VRF also split type with the inverter. Sorry, split type with inverter, or you can use the VRF because it's 5 stories. So the tonnage will be around, I can say, 5 stories. 100 tons, I think. 100 rooms or 80 rooms or something like that, I think. Maybe is but the price is a little bit higher than the inverter. If the inverter is very cheap now in Thailand, you can buy any.
อาจารย์ I would like to ask whether for architectural students studio that they do home office เนี่ย can they also use VRF as well so that they can organize the place for condensing units nicely and access nicely for each several floors and they have one space for VRF for example so that they can design.
This one is very suitable if nah, the in the dormitory we provide okay we can charge them the bill of the aircon. But if they don't, they pay only the electrical bill and we charge over on that. They have to think very details on this. They can put the VRF in the system also, but they have to think how to calculate the monthly electrical bill for each room.
Because different ใช่ไหมdifferent owners should
Correct,
be
different owner they
separate
will,
meter.
but sometimes when you combine everything together and you measure by the hours of operation of the fan coil, you can get more benefit if you are the owner because as I told you, the condensing unit it can sharing the load. So when that room is already cold, so the electronic expansion valve is closed already, so it not occupy the condensing, but it's keep running, so you can charge them. So it depends on how to charge the tenants or the people who are in the room. If they are charging by the hours of the operation in fan coil, that's I 100% recommend to use VRF because you can make profit out of it at least 20%.
I see. But anyway, students have to prepare a kind of balcony for putting the condensing units with the access in their design, not
Yes.
too far from the room.
You can look into the current condominium in Thailand now. They have so many designs. Some design they are good. Some design they are bad. So you can see that this one you can use your gut feeling that this one is easy to ventilate. This one is not easy to ventilate. It will create more heat, and they cannot clear the hot air.
I also suggest maybe they can put the drying area next to near the condensing unit so that they can dry the clothes very fast.
Correct.
In their design, ใช่ไหม near the
but you have
laundry
to but you have to clean the condensing unit also. Otherwise, your clothes will be dirty because of the dust.
อ๋อค่ะค่ะ
Okay,นะครับ. So I think that's about it today. I very quite enjoy and thank you for listening and sharing. Okay, ครับ. So any question? So เงียบหมดเลยสงสัยหิวข้าวแล้ว
มีคำถามอะไรไหม any question students I know it's very very new to you นะคะ but please think along and มีอะไรถามไหม So actually they are the second year students and their design is more like residential condominiums and so on, not very complicated yet. So the project is, so I can make a summary my observation from your lecture นะคะ for students. Okay, you have learned about the principles of air conditioning where there are four components ใช่ไหม the one that is more related to students is one is evaporating unit which is like a cooling part ใช่ไหม in the building and condensing unit where you put it outside of the building where students need to be careful where to put it must be shaded ใช่ไหม and well ventilation and not too strong wind that they cannot eject the heat นะคะ as well as good for maintenance นะคะ they have to have access and maybe the water piping for cleaning นะคะ for condensing unit and for the green building also the location to put condensing unit you shouldn't put it near your neighborhood otherwise your neighborhood gonna be too hot นะคะ so the condensing unit locations you have to be careful นะคะ and not too far if it's like split type unit should be like 4 to 8 meters but for VRF you can put it farther away from your air handling unit นะคะ so split type นะคะ แล้วก็มี VRF นะคะ for maybe multiple that they can share the load นะคะ and then we have air cool and water cool package system ใช่ไหม with the chiller มีอะไรอีกนะอาจารย์มีอันนี้
มี water cool chiller มี air cool chiller นะครับแต่ผมยังไม่ได้พูดเรื่องที่มันเป็น advanced ส่วนนี้ก็คือเรื่องของตัวการคุมพลังงานหรืออะไรแต่ผมว่าไว้
ยังเอาไว้3 ปี 4ก็ได้อาจารย์
ได้ครับ
ตอนนี้ก็มึนก็หมายความว่าก็
ผมว่า
ค่อนข้าง
ต้อง
เยอะ
พาไปดูตึกผมว่าในบางมดเองก็มีตึกที่ใช้เกือบจะครบทุกแบบมั้งครับเท่าที่ผมจำได้
ใช่ตอนนี้
แล้วก็หลายตึกใช้เป็นทองแดงด้วยซ้ำ condensing ทองแดงถ้าผมจำไม่ผิดผมเคยไปอันนั้นก็ condensing ทองแดงคือ
condensing unit ไปหมดเลย3 ปีไปเพราะว่ามันติดทะเล
ใช่ครับก็มีตัวที่ ขายไปสมัยก่อนก็จะเป็นพวกมีคอยทองแดงด้วย ตอนแรกก็สงสัยว่าทำไมต้องคอยทองแดงเขาบอกว่าตรงนั้นมันใกล้ทะเล เพราะฉะนั้นก็ใช่ครับก็คือทองแดงก็จะผูกกร่อนเหมือนกันแต่ว่าช้ากว่าเยอะครับ
ใช่ตอนนี้KMUTT is conducting the learning environment เขาจะมีเป็น QR code at 12 stations around the campus. There are 2 to 3 stations regarding air conditioning system นะคะ they will finish in 4 to 5 months. Students can go to the main campus and follow the learning route นะคะ You can learn about sustainable universities and buildings on the main campus ค่ะ
Also I heard that in ที่บางมด they have teacher who are doing on the radiant cooling
ค่ะ
research
มีอาจารย์พัฒนาอาจารย์สุพงศ์ Yes I'm very close to them ค่ะ because I go look and actually there is this laboratory at Bang Khun Tien campus on the building nearby but the campus they asked us not to organize the field trip this semester not officially because they are afraid of the COVID-19 ค่ะYes and the professors found that the radiant cooling with dedicated outdoor air system to remove the moisture and to put the fresh air intake for the room เนี่ย it can save around up to 70% from their study and the radiant cooling technique เนี่ยshould be used in the inner part, not the perimeter near the windows because of the sudden load that the radiant cooling cannot taking care of นะคะค่ะ Also I have the new student that I want to organize the field trip to Project H but the owner asked perhaps in May difficult นะคะ difficult so my building has just finishedนะคะ so we will see if the situation is better I could organize the field trip for students to the Project H นะคะ at Rama 13นะคะ if I organize I invite you to อาจารย์อุทัย to see I also have the radiant cooling technique and dedicated outdoor air I have the solar cell I have the chiller room like an exhibition I have chiller room on the first floor with the ease of maintenance for the chiller because the owner sells also the refrigerant system for 7-Eleven and many buildings ค่ะ
ครับ
student do you have any more questions I hope you learn a lot from him นะคะ and let me see forงั้นก็มีอะไรไหม students นะคะ so if you don't have any question นะคะ we dismiss the class นะคะ and thank you very much ค่ะคุณอุทัย for your informative lecture ค่ะขอบพระคุณค่ะสวัสดีค่ะ
สวัสดีครับ
thank you very much student we dismiss ค่ะ bye ค่ะ